Sir, you're on mute. We can't hear you.
See, okay, now you can hear me, right?
Yes.
So yesterday we talked about alternate interior angle theorem, didn't we? Alternate interior angle theorem. And that is, what is alternate interior angle theorem? If these two angles, the interior angles, not on the same side, interior angles on the opposite sides, alternate interior angles, if they are congruent, that means these two lines are, tell me, if these two angles are congruent, then these two lines are, if you have two lines and a transversal.
Raghav, can you say the answer?
Yes, what is the answer?
So then line L and line M are parallel.
Lines L and M are parallel. We just write it like this. L is parallel to M, or M is parallel to L. That is the alternate interior angle theorem. How did we prove that? You remember? Raghav?
Sir, we use proof by contradiction, and then if the lines are not parallel, then they must intersect at a point, and hence
Yes.
a new triangle is formed. Then by the exterior angle theorem, angle 2 must be greater than angle 1. So
Exactly.
Contradiction. Hence,
that will be a contradiction.
L and M are parallel.
Yes. That will be a contradiction. What does it contradict?
It contradicts the fact that we have assumed in the start that angle 1 and angle 2 are equal.
Exactly. This is our premise. This is our assumption. This is our hypothesis. If the lines meet, then they form a triangle, in which case we have an exterior angle, which therefore has to be bigger than any interior angle. But that contradicts our premise. Therefore, the lines cannot meet. Many people confuse the alternate interior angle theorem with its converse. What is the converse of alternate interior angle theorem? Shmyan, go ahead.
That if the two lines L and M are parallel, then angles 1 and 2 are congruent.
Yes. See, many people, well, most people confuse AIAT with its converse. So if you are asked, what is AIAT? One way to remember it is, start with this. If the alternate interior angles are congruent, then you will never go wrong. Okay? If the alternate interior angles are congruent, then the lines are parallel. You might find that it's easy to remember, but after a while, you will be confused unless you have a way to remember. So you always start with alternate interior angles, congruent, then the lines are parallel. The converse is not automatically true. We will come to that later today, okay? Now, alternate interior angle theorem has enormous consequences. Given a line and a point, you can drop a perpendicular to this line. I think that is proposition, I can't remember. That is proposition 12. Proposition 12 of Euclid's Elements allows you, shows you how to construct from a point not on the line, a perpendicular to the line. So this is possible. Proposition 11 of Euclid's Elements, this is allowed by proposition 12. Proposition 11 allows us to draw a straight line perpendicular to this line. There. So between proposition 12 and proposition 11, we have constructions that allow us to draw this configuration. Then call this M. What do you think about these two lines? Are they parallel? Is M parallel to L?
Yes, sir. They are parallel, sir. Yes, sir. Line
Why?
is parallel by AIAT.
Exactly. See, so given a line L and a point not on L, we can draw a line parallel to the given line. Well, it is not surprising for people, because if you are given a line and a point not on the line, you can take the ruler, you can take a straight edge and draw through P what looks like a line parallel to L. And we call it, hey, there is your parallel. But that doesn't prove that it is the parallel. Anushka?
Sir, because when we draw a line parallel to to L using a straight edge or a ruler, it doesn't necessarily look like it's parallel. So
Yes.
so using both propositions 11 and 12, we can construct two separate lines that are parallel to each other.
Yes, you can. You see, when you draw, it can only look parallel. There is no proof that it is parallel, right, Anushka?
Yes, sir.
But if you insist that these angles are equal, then the line will be parallel. The problem is, you can't even verify mechanically that these two angles are 90 degrees each. Agreed?
Yes, sir. Using a protractor.
Yes. And even with a protractor, you cannot. You can only, okay, it is equal, but you can never use mechanical instruments to draw equal angles. You can only have them approximately equal. So this is why we need mathematics. Mathematics says we can draw another angle that is congruent to this, because the construction theorems tell us it can be done. Agreed? The fact that it can be done means there does exist a line that is perpendicular to this line. There exists. That is what the constructions really tell us. There exists a line M perpendicular to this one, and we just draw it by hand. That doesn't mean that is the line. Oh, how did my diagram go away? Did anybody erase it? How do I get it back? Good. Now, yesterday we said, does this mean that there is only one line through P parallel to L? We have shown that there is Raghav.
Yes, sir. Sir, yesterday we showed that there is at least one line parallel to
Yes.
L.
Yeah, we have proved using AIAT that through a point not on a line, there is at least one line because we have exhibited one line. Agreed? This
Yes,
is
sir.
like I told you, if your mom tells you to go to that building that you own at night and turn on the light, you open the door to that building. As soon as you open, what do you see?
A head moving.
A head moving. So you panic. You immediately slam the door and come right back and tell your mom, Mom, there is exactly one person in that room. Would you say that? What
No,
will
sir.
you report to your mom?
Mom,
Sir, you would say, I saw at least one person in that room.
Yes, at least, Mom, I saw there is at least one person. You cannot say I saw at least one person. You saw one person, right? You will say there exists at least one person in that room. There exists. Similarly, alternate interior angle theorem says through a point not on a line, there exists at least one line parallel to the given line. We will return to this soon. Let's go to, we will be doing one theorem before we go on to Euclidean geometry, where we add the fifth postulate. And we will stay with Euclidean geometry for 2 classes, maybe 1 class, and then we pass on to hyperbolic geometry. So this last theorem that we will be doing will be called Zachary. This was discovered independently, Legendre. Zachary and Legendre. Zachary was a priest, Legendre was a soldier. Vagishan. Yes.
So I had like done the proof as a homework.
Say that again.
You told us you gave a lemma from this and we had proved that right.
Yeah. We said, oh, by the way, Vagishan, what is this theorem?
This theorem is about like the angle sums of triangle.
Angle sum of triangle is at most
180 degree.
Notice that at most is written as 2 words because don't write it as at most. There is no word called at most. Is there a word? No. This really means what? At
It is less than or equal to.
No. This means at the most. Less than or equal to. At the most. So you see, we omit that word and write it as at most. Okay. So it's at most 90 degrees. And as you said, this is like is so this is kind of funny. E is less than or equal. So in triangle, this is not good. In a triangle, angle sum is less than or equal to 180 degrees. Because this way I wrote is not good. Of course, they both mean the same thing. Triangle is not less than or equal to 90 degrees. Angle sum is. So to prove this, we first proved a lemma yesterday. That was part of your homework. I only did one part. Angle sum of any two angles in a triangle is less than if you add any two angles, yes. Raghav.
Yes, sir. It is less than 180 degrees.
Less than 180 degrees. So what is less than 180 degrees?
So the sum of any two angles.
Sum is less than 180. Notice, we are going to prove that if you add one more angle, the remaining angle, then you can have even 180 degrees, but no more. Do you see the distinction between this theorem and this lemma? Here we are dealing with two angles. Here we are dealing with all three angles. Parth, is that clear? This lemma deals with any two angles. Yesterday we took a triangle and showed that if you added two particular angles, it was less than 180. The homework was that you also consider the remaining two pairs and prove this lemma. There is a second lemma. Yes, Shmayan? Smayan.
Yeah, so sir, in the lemma 1, to prove that the other two pairs, can't you just extend the line on the third?
Yeah, sure. You have to do the construction.
Any two given angles, and that's what proves the lemma, right?
Yeah, you will be. See, you have to do something to show that. It might be extending. I'm sure it has to do with extending one side.
Okay.
Yes. Who else would like to talk about it? Raghav or Vagishan? You have a comment on the homework?
Yes, I had solved it by extending all the sides.
I see. Yeah. Anushka, you have a question. Anushka has a question.
No, sir, I have a question. I just wanted to talk about the homework.
You want to talk about the homework? Oh, you do?
Yes.
Okay, let's get out of this here. So we had one, two, three. We extended it that way. 4. Now we showed that what What did we show in class?
We showed that the angles 1 and angle 3 have some at most 180.
Did we show not at most, less than?
Sorry, yeah, less than
There's a
180.
difference.
Yes,
180 degrees.
sorry. Not
Yes.
1 plus 2. We showed 1 plus 3, I think.
Yes. Oh, wait a minute. Ah, I just realized. Homework is wrong. Thank you.
Actually, no, sir. In the homework, I put it as that you did that you have to do the 1 and 2 pair and the 2 and 3 pair.
Yes, I just realized the oh no, homework is not wrong.
Yes,
I am
sir.
glad. Homework is okay.
Yes.
You see, we proved that, let me see, 1 plus 2. How was it? We know by exterior angle theorem that 1 is less than 4. We also know that 3 plus 4 equals 180 degrees. So here you have 4 is the 4 is equal to 180 degrees, and therefore 180 degrees minus 3
1
degrees
1
minus,
plus 3 is equal.
yeah, 180 minus 3. So this is what is, so 180 minus 3 degree minus 3 is less than, is what, greater than 1,
So,
and therefore 180 degrees is bigger than 1 plus 1, 3. That's what we did in class. So now what should we do?
sir, so for now we have to prove that 1 plus 2 is less than 180.
Yeah.
So you extend the side. So suppose that angle 1 has point A, angle 2 has point B, and angle 3 has point C.
So 1, 2, 3. It is a matter of extending a side. Which side do you want to extend?
Sir, I want to extend side AB.
Okay, let me draw it like that. You want to extend side AB this way or that way?
That way. Across.
AB means this way, right?
Yes.
Yes. If you do that, then you get this angle.
So suppose that angle is angle 4.
Yeah, might as well call it angle 4. That's how you do it.
And so according to the EAT,
Yeah,
one is less than angle 4, and angle 2 plus angle 4 is 180. So you can isolate angle 4 by
yes.
180 minus 2 and substitute, and
yes,
then you can rearrange.
that's right. That's how that problem is done. So good. So we have done lemma 1. Angle sum, any two angles add up to less than 180 degrees. Good. Lemma 2 will be, what is lemma 2? For any triangle ABC, their axis, triangle A1, B1, C1, having same angle sum, but where Angle 1 is less than or equal to angle A. Let us, to understand this lemma, let us draw a triangle. We are given a triangle A, B, C. We don't know what the angle sum of a triangle is. Remember, we are starting from nothing. All we have are those 4 axioms. We don't know what the angle sum of a triangle is. Remember,
So
we are
Bhagyan
not
wants to
in.
disprove the exterior angle theorem.
Yeah, we'll come to that. All we have is the exterior angle theorem and the alternate interior angle theorem. We don't know what the sum of the angles in a triangle is. This is not school geometry. This is the real mathematics we are talking about. In school geometry, they are talking about real mathematics, about Euclidean's plane. We are not in Euclidean plane. We are in the neutral plane, which contains Euclidean plane. All right. What this lemma says is that if you have a triangle A, it is possible to construct another triangle that has the same sum for the angle, whatever that sum is, where one angle, they call it A1, is less than or equal to half of this angle. The reason you want it is we are trying to prove the Zachary-Legendre theorem. We need this result. You will see. This is a most beautiful proof. Now, we need to produce a triangle. Remember, we don't know what the angle sum of this triangle is. But it does have an angle sum. Don't you agree? Because we already drew it. It has an angle sum. So, I'm going to extend this. No. I am going to find the midpoint of this. You can find the midpoint by proposition 9, I believe, in Euclid's Elements. This means 1. There are 13 books. In the first book of the Elements by Euclid, the 9th proposition, I believe, no, the 10th proposition, the 9th will show you how to bisect an angle. The 10th proposition has a construction that allows you to bisect a given segment. So you can find this point. Now you draw this line. and find a point. Call this point E. Whoa. I will call this point E. Then you go here and find a point. These are all constructions that is allowed. It is, you can't measure and get something exact. You have to have theorems that say it is possible. There exists an E, there exists an F, so that this distance is equal to this distance, namely AE equals EF. Actually, you have to write, when you write AE equals EF, strictly speaking, you have to put this. This says the segment AE is equal to the segment EF. But we are lazy. We will omit this bar or line segment over this. And just so we don't have too much writing here to confuse our reasoning. So AE equals EF. Then you join what? Join that. And oh, I made a mistake. Haha. Join this. Now, I say triangle CAE is congruent to triangle EBF by ASA. Do you agree? This triangle is congruent to this triangle. Do you agree? Side, no. SAS. Side, there is a side equal to this side. Is this side equal to this side? Because by construction, CE equals EB. And this angle, is it equal to this angle? When you have two lines, is this angle equal to this angle? Let's call this 1, 2, 3. Who can prove it? Who should I call on? How do I call on? Because I don't know who raised the hand.
I unmuted Anushka.
No, that was for a doubt.
Okay, someone.
Okay, I
Okay,
unmuted Raghav now.
Okay, who is going to prove this? That the vertical angles are equal. Okay, who is going to volunteer?
So can I do Raghav?
Rahul?
Sir, Raghav.
Raghav, yes, Raghav.
Yes, sir. Sir, so first, angle 2 will be equal to 180 minus angle 3.
Angle 2 equals 180 minus angle 3.
3. Yes, sir. And angle
Yes.
1 is
Equals,
equal to 180 minus angle 2,
yes,
which is equal to 180 minus 180 plus angle 3.
that's the proof. Angle 1 equals angle 3. Vertical angles are congruent. What about these two?
So even they are congruent.
Similarly, they are congruent. Excellent.
So
Let us
Bhagyashan wants
call,
to disprove exterior angle theorem.
yeah, hold on. So this is angle. I'm going to label these angles. Since these two triangles are congruent, where is angle 2? Is angle 2 then equal to angle 6? From this equation, corresponding angles in the triangles are congruent. What is the angle corresponding to 2 in this triangle? Angle 2 is opposite this side. Which angle is opposite that side in the other triangle? Angle 2 is opposite this side in that triangle. Which angle is opposite the corresponding side in the other triangle? In this triangle, which angle is opposite this side? Anyone? See, corresponding angles are equal in congruent triangles.
Raghav, I unmuted you.
Yes. Sir, so angle 2 shall be equal to angle 6.
That's right. Angle 2 equals angle 6.
So,
How about angle 1?
so it will be equal to angle 5.
Angle 1 equals angle 5. Excellent. Now, let's see. The angle sum of triangle ABC, I will call it SABC. I don't know what it is. I don't know what the value is, but it has a value. I just call it the sum S. And that is equal to, I will just say angle A plus B plus C. And that is angle 1. And what is angle B?
So angle B is angle 2 plus angle 3.
And what is angle, wait a minute. A is, this is A, angle 2 plus angle 3. B is angle 4. I made a mistake. And C is angle
1.
1. Agreed? 1 plus 2 plus 3 plus 4. That is the angle sum of triangle ABC. Do you agree?
Yes, sir.
But angle 1 is angle 5. Angle 2 is what?
Angle 6.
Plus angle 3 plus angle 4. So what is 5 plus 6 plus 5 plus 6 plus 3 plus 4?
Sir, S of
Isn't
line
that
ABF.
ABF? Wow! We just constructed a triangle that has the same angle sum as ABC. That's an interesting construction. We constructed a new triangle that has the same angle sum as ABC. Now let's look at angle A. Angle 2 plus angle 3 equals A. Then either angle 3 is less than or equal to half of angle A or not. I can't see anybody now. What happened? Manu? Manu? Sai, can you hear me? Yes, I can't see anybody else, Sai.
We can
Maybe
hear
on your
you,
sharing
sir.
screen, the videos are hidden as for the shared screen because I can see most of the people.
So how do I get to see all of you again? I
Sir,
can.
there should be a box on the side that shows you the videos.
I didn't do anything. Can you all see me?
Yes, sir, we can see you.
Now I can see all of you. I think I can see Smayan, Raghav, Anushka, Parth. 2 people raised their hand. I can
Yeah.
see Devansh now. Okay, I think they are back now. You are back now. Siddharth raised his hand. Okay, let me.
I'd like to. Okay, so now. Okay, so but if we get angle 3 is less than or equal to half a way, what else can we deduce from that information?
Yes, that means in this triangle, this angle is less than or equal to half of A. So if you take then triangle ABF and call this A1, that means that this new triangle has an angle A1 that is less than or equal to half of A. Let us hold there. Let us hold our thought. You agree that either this is less than or equal to half of A or not. Agreed? If it is, then call this triangle A1 B1, C1. We will then have angle A1. This will be A1, B1, C1. Simply relabel. You already have the triangle. Then this angle will be less than or equal to half of A. Let us wait there for everybody to understand it. We constructed S. Vagishan.
Yes, so my doubt is like if is triangle AC
I can't hear you. Say louder.
is triangle ABC and triangle ABF, both of them are isosceles in this case because they are getting bisected.
Yeah, but we don't have to worry about this. We are taking two general triangles, okay? It may be that they are isosceles, in which case, yes, you are right. In which case, this will be half of A, right?
Yeah.
But good point. These don't have to be isosceles.
Yes.
The way I draw it, did you know that if you draw a triangle, most of the time, you are going to get an isosceles triangle. What is the opposite of a scalene triangle? Is hard to draw. A triangle with all sides different is hard to draw, but you can. That's actually very funny. How many people understand, agree with this? That if this is less than this angle, then we can rename this angle A1, B1, C1, and we are okay. Then angle A1 in that triangle will be less than or equal to half of A.
So
Right?
I have a doubt. Sir, why
We are
is
not done. We are not done. We are
I
saying
have a
that.
doubt in angle 3 is lesser than equal to angle 1/2 of 1/2 of A.
Yeah, we
In
don't
that
have to worry
line.
about C. We don't have to worry about C now.
Not
We
C,
have this.
A.
Say that.
Yeah, you have written that angle 3 is lesser than equal to half of angle A. Right?
Yes.
I have a doubt in that.
Okay, what I am saying is, we know angle 2 plus angle 3 is A. Agreed?
Yes.
When you have two angles, adding it to an angle, either they should both be equal or not equal. Agreed?
Yes.
Then one of them, if they are not equal, one of them is less than half of A. Agreed?
Yes.
So we can say that either angle 3 is less than or equal to angle A or not. Agreed?
Oh, I understand. I thought you were telling that angle 3 is lesser than equal to half of angle A. That made me confused because it can be greater.
So there we are. Angle 3 is less than or equal to half of A. In that case, if it is that this is less than or equal to half of this angle, we got a triangle that has one angle less than or equal to half of A. Agreed? If we, then all you have to do is erase this original triangle and relabel this triangle as A1, B1, C1. We are done. Do you see that? Anushka, do you see that? Smayan, do you see that? If this angle is less than or equal to half of this angle, then we got our triangle. A1, B1, C1, just relabel it. Then the angle A1 in the new triangle will be less than or equal to half of A. If it is not, what happens? We are not done. Then angle 2 will be, what can you say? Raghav. If this is not less than or equal to half of A, angle 2 will be angle 2 plus angle 3 is A. If this is bigger than half of A, this will be less than half of A, wouldn't it? One of them has to be less than or equal to half of A. If somebody gives you 100 rupees in 2 bunches and says, okay, my hand has 100 rupees, then either this hand has at most 50 rupees or this hand has at most 50 rupees. Agreed? If this hand has more than 50 rupees, then this has less than 50 rupees. Right? So that is all we are saying. If angle 2 plus angle 3 add up to A, if angle 3 is not satisfying this, then angle 2 must satisfy that. Agreed? But if angle 2 satisfies that, what can you say? Angle 2 is angle 6, isn't it, Raghav? But if angle 2 is angle 6 is less than or equal to half of A. Get it?
Yes,
and
sir.
then again you have a new triangle. This time, watch this. You call this A1, this one B1,
B1. Sir, and A will be C1.
C1. So you have a new triangle where an angle is less than or equal to half of A. Get it?
Yes, sir.
So you have constructed, you have proved the theorem. This triangle that you constructed has one of its angles less than or equal to half of A.
Yes, sir.
So that was not an easy theorem to prove. So we have found lemma 2. If S triangle ABC there exists triangle A1, B1, C1, so that what? Yes, triangle A1, B1, C1 equals S triangle ABC, and A is, well, A1 is less than or equal to half of A. That's a lot of proof we did, didn't we? It is possible to find a triangle that has the same angle sum. Remember, we don't know what that is. We know A1 plus B1 plus C1 is A plus B plus C. A1 plus B1 plus C1 is A plus B plus C, and A1 is less than or equal to half of A. Okay? That is our lemma 2. Now, using lemma 1 and lemma 2, we can prove the Zachary-Legendre theorem, which says in a triangle ABC, A plus B plus C is less than or equal to 180 degrees. That is the theorem. So let's prove it by contradiction. What is the opposite of this? Raghav. What is the opposite of
Greater
this?
than. Sir, it will be greater than.
A plus B plus C.
Is greater
Let's
than.
assume A plus B plus C is bigger than 180 degrees. Agreed?
Yes, sir.
That means A plus B plus C equals 180 plus, I don't know, some number P bigger than 0. Agreed?
Yes, sir.
If A plus B plus C is bigger than 180, then it is 180 plus some positive number, real number. So here we have then a triangle with angle sum 180 plus BP. What does this lemma tell us? This lemma then tells us by lemma 2, have you seen this notation before? This symbol, this means there exists. There exists. Instead of writing these two words, you can use this symbol, there exists. By lemma 2, there exists A1, B1, C1, so that what? A1 is less than or equal to half of A. You see how we are using that lemma? If we have a triangle ABC with this angle sum, then we have a triangle A1, B1, C1 . So we have A1 plus B1 plus C1 equal to A plus B plus C, and A1 is less than or equal to half of A. Wait a minute, but then I have a triangle A2, B2, C2, so that A2 plus B2 plus C2 equals A1 plus B1 plus C1, and A2 less than or equal to half of A1. Do you agree? I use the lemma 2 on triangle A1, B1, C1. Agreed? I can find a new triangle A2, B2, C2 that has the same angle sum as A1, B1, C1, and where there is an angle A2 less than or equal to half of A1. Isn't that beautiful? Do I stop here? But wait a minute. But A1 is less than or equal to half of A. So this will be half of A. That means A2 is less than or equal to 1 over 2 squared A. Whoa. Wait a minute. I can now find a triangle A3, B3, C3, where A3 plus B3 plus C3 equals A2 plus B2 plus C2. And A3 is less than or equal to half of A2. Vagishan. Yes, Vagishan. You have a question?
Yes. So
Say it loud.
Okay, when we are telling A2 is equal to B2 is equal plus C2, so when we are doing that thing, let's say AN plus BN
That's right.
plus
You are-
CN is equal to no, greater than or equal to 1 over
Actually,
2
these are all
power
equal to, yeah, less than or, right.
A n minus 1.
Yeah, or we can put it n. No, less than or equal to A. We are still connected to the original triangle.
Yeah, anyway, that's what. So,
Excellent. You see, when we keep on going, we will get an nth triangle with the same angle sum as A plus B plus C. But where, so I can get a triangle AN plus BN plus CN, triangle AN, BN, CN, where AN plus BN plus CN is AN minus 1, BN minus 1, CN minus 1, and then they keep on filtering down, and this will be true. And AN is less than or equal to 1 over 2 to the n A. Let us stop there for a moment. Our proof is almost finished. It's going to jump out at you shortly, okay? What did we do so far? We started with a triangle where we thought the angle sum was 180 plus P. Then our lemma 2 allows us to construct a triangle A1, B1, C1. There exists triangle, I forgot to put triangle. So that this is true. Do you agree with that step? Where did that come from? So you agree with that step. Given a triangle A plus B plus C with an angle sum, you can find another triangle with the same angle sum. Right? That's lemma 2. And where A1 is less than or equal to half of A. But then you can find another triangle with the same angle sum as this triangle, which has the same angle sum as this triangle, where the new triangle has an angle that is less than or equal to half of A1, but A1 is less than or equal to half of A. Therefore, A2 has to be less than or equal to half of A. So A2 is less than or equal to 1 over 2 squared A. But then you can continue. You can find another triangle which has this property, but the same angle sum again. You can continue. At the nth stage, you are still connected to the original triangle. And this is what, agreed? Hey, wait a minute. You can keep going until this is less than P, our original P. Okay? Suppose you give me P as 1 over a million. Then I keep going. And I can keep on increasing n at each step and become less than this. Agreed? See, 10 to the power 6 is less than, I don't know, it is 10 is less than 2 to the power 4. Agreed? Therefore, 10 to the power 6 is less than 2 to the power 4 to the power 6, which is 2 to the power 24. So even if you give me a P that is so small, all I need to do is construct 24 triangles successively, and I will get a P. I will get an angle that is smaller than this P. But what does that mean? That means that AN plus BN plus CN is still A plus B plus C, which is 180 plus P. But this angle is less than P. If this angle is less than P, what do you think that will be? If the whole thing is 180 plus P, and if this is less than P, how? Because yes, Raghav.
So then Bn plus Cn shall be greater than 180.
Tremendous, Raghav. What is wrong with that?
So then it becomes a contradiction, sir.
What? How does it contradict?
So because sum of two angles in a triangle is always
Lemma
smaller
yes.
than 180.
Lemma 1 says in
Lemma
a triangle, if you add any two angles, it is less than 180. Whoa! That is the contradiction. We are done. Therefore, it is not possible that A plus B plus C is 180 plus P. It is not possible that A plus B plus C is bigger than 180. Therefore, A plus B plus C has to be less than or equal to 180. That is the proof. Whoa, that is tremendous. You, at home, you read that proof again, okay? And let me see. How do I save this? Just in case we need to come back to it. I have never saved.
So I'll take a screenshot of it.
Where do I go?
So I'll just take a screenshot of it. But there should be a button that says save.
Where is that button?
Well, how I use it is I usually.
Oh, save.
Yeah.
Good. So now,
I'll
if
I'll take a screenshot of it and post it in the
okay,
materials just in case. So
I
can you
think
go
we
to
may
the
have
other
gotten it
slide?
now.
So can you go to the other slide?
How do I go to the other slide now?
There'll be a button that says, there'll be a screen near the bottom. Just click back on that.
Yeah, I tried to do that. I'm not getting it. Anyway, so we started with a triangle A plus B plus C. We want to show that it is at most 180 degrees. So we assumed it is not. That is, it is assumed that it is bigger than 180 degrees. That is to say that A plus B plus C is 180 plus P, where P is bigger than 0. Then we constructed a triangle AN plus BN plus CN, where it is still 180 plus P, but AN is, tell me, less than or equal to 1 over 2 to the N A, the AN, you take N so big that it is less than P, okay? If AN is less than P, therefore BN plus CN is greater than or equal to 180 degrees. In this equation, if one of them is less than P, the other two should be at least the remaining part. Agreed? And this will contradict what? Lemma 1. And that, therefore, we have A plus B plus C cannot be greater. This cannot happen. This is a long proof. This is probably the longest proof you have seen in your life. Therefore, it took a while. Read about this. This is a famous and historic theorem. And it is very important. It shows that this is true. Clear. Now, we will add to the first 4 propositions of neutral geometry. We will add the 5th postulate, which says, if you have 2 lines and this is 1, this is 2. If 1 plus 2, angle 1 plus 2 is less than 180 degrees, then L and M meet on the side of angle 1 and angle 2. It will meet on this side, not on the opposite side. That is the 5th postulate of Euclid. We are going to prove, I know time is up. This is a lot of writing. A gentleman couple of 100 years ago by name John Playfair. Funny name, isn't it? He came up with this idea. Suppose you have a straight line and you have a point here. Suppose you say instead of all this stuff, through P, there is only one line parallel to L. Then he says that axiom can replace this axiom. In other words, through a point not on a line, there is a unique parallel to the line, and that is nowadays known as the parallel postulate. It is also called Playfair's postulate. So Euclid's fifth, these two are actually equivalent. I'm leaving it on the board for you to write it down. This is Euclid's postulate, fifth postulate. We are adding to the first four, 1, 2, 3, 4. Now you have 5. And this is when you get Euclidean geometry. So postulate 1 plus postulate 2 plus postulate 3 plus postulate 4, that is neutral geometry. When you add postulate 5, what do you get? Euclidean geometry. Now, our job is to show that this parallel postulate and the Euclid's fifth postulate are equivalent. Because it is so simple. Take a line, take a point. This is saying that there is only one parallel. Remember, alternate interior angle theorem showed us there is at least one parallel, right? Now we are saying there is exactly one parallel. That is when you get Euclidean geometry. This says there is exactly one parallel. But this says that if you have two lines and a transversal and the angles on one side add up to less than 180, the lines must meet. They are not parallel. It turns out this statement is equivalent to this statement. So I will just prove that Euclid's fifth postulate implies parallel postulate. And I'm going to leave the other part as your homework. You have to, the homework is you have to show that the parallel postulate is equivalent to the fifth postulate. No, maybe I should prove this one. The other one is easier. That is the homework. I will do this one. I'm going to show that parallel postulate implies Euclid's fifth. So how do I go? The reason I am doing it, although we are out of time, is if I don't do it, you will have trouble doing this. This proof is easier than this one, okay? So I'm going to assume Euclid's fifth postulate. It says, if I have two lines, if I have a point, take a point, we have to show that actually I was right the first time. you have to show that if you have two lines, so that angle 1 plus angle 2 is less than 180 degrees. What do you need to show to prove Euclid's fifth postulate? What is Euclid's fifth postulate? Raghav?
Yes, sir. So Euclid's fifth postulate is that if angle 2 and angle 1 together, if the sum is less than 180 degrees, then the lines L and M, they meet on the same side.
Yes, we have to show that these two lines will meet. If 1 plus 2 is less than 180, these two lines will meet. That is Euclid's fifth postulate. Well, if 1 plus 2, watch this. If 1 plus 2 is less than 180, what about angle 1 plus 3?
So they are also 180.
That means that angle 2 is less than angle 3. Do you agree?
Yes, sir.
If 1 plus 2 is less than 180, but 1 plus 3 is 180, that means angle 2 is less than 3. Agreed?
Yes, sir.
If so, I can construct angle 3 here. That will be angle 3. I can get a new line here. That means by parallel postulate, by alternate interior angle theorem, what can you say?
Lines L and N are parallel.
AIAT implies N and L are parallel. But parallel postulate says how many parallels are there through P to L?
Only one.
Only one. That means M is not parallel to L. Agreed?
Yes, sir.
If M is not parallel to L, M meets L. Agreed?
Yes, sir.
Wow, that's Euclid's fifth, almost. We have to show that it will meet here. So let's assume that it doesn't. Let's say that it meets here. Funny. If it meets there, then you have a triangle. Remember, this is a straight line. This will be a triangle. Okay? That will mean that this will be the exterior angle. Let me clear the drawings. No. Let me clear the drawing. If they don't meet on this side, then they will, let's say they meet on this side. Remember, angle 1 plus angle 2 is less than 180 degrees. Angle 1 plus angle 3 is equal to 180 degrees. Therefore, angle 2 is less than 183 degrees. So we construct here, we found that this is the parallel, therefore this is not, therefore these lines meet. I am trying to show that it doesn't meet on that side. If it meets on that side, what happens? Remember? Then angle 2 becomes the exterior angle for this triangle. This is like QPR. If it meets on that side, angle 2 will be the exterior angle. The exterior angle has to be bigger than the
Angle 3.
angle 3. Whoa!
Contradiction.
Contradiction. Therefore, this cannot happen. It must meet on that side. It's a beautiful proof. We just proved that parallel postulate, PP, implies Euclid's fifth. Your homework is prove that Euclid's fifth postulate implies parallel postulate. Do not look on the internet. You are hurting yourself. The proof has to be there. So here you have to assume, this is your homework. Here you have to assume that you have two lines and you have a point P. You have to prove that through point P, there is only one line. So what you do is, you construct a perpendicular, okay? You construct a perpendicular. And then you can construct another perpendicular. And you prove that you cannot have another line that is parallel to L. Prove that there cannot be another line parallel to L. Because if there cannot be another line, you have proved parallel postulate. Agreed? Prove that there is no other line through P parallel to L. I have, and this, now it is immediate. Okay? I think we have exceeded the time by 14 minutes, so I am going to quit this moment. This is the homework. After everybody writes it down, Siddharth.
Okay, so we have to prove that there is exactly one line through point
No,
P.
yes, if we explain it even a tiny
I
bit.
have a doubt.
Yeah,
I have only one doubt. How is, so using a similar process, what we did to convert parallel postulate and make it imply axiom 5, similar process, though in
similar,
reverse,
yes,
we use
yes,
it.
similar process. And this is all you have to do now.
All
Similar
we have.
process.
So
The
this is
problem-
all we have the information.
Yes. The only information you have is Euclid's fifth postulate.
Why
That
did you
is
write my name?
Siddharth.
Why?
I got it.
Why did you write my name?
Oh, I don't know how my brain goes bananas.
You're not supposed to write my name.
This is
there.
all you know. In
Oh.
this, you are told that if 1 plus 2 is less than 180, they meet. You use that to prove this. Okay? If I say one more thing, then the proof is done. I shouldn't say that. You should discover it. Can I go? Can I leave now?
Yes, sir.
Okay.
Everyone can leave.
Bye bye now.